Alright, this is Matthew Goodenough. I'm in fall semester of 2023. This is Engineer 120 at New Mexico State University, and this is my lab circuit 1. So I'm going to start off with the first circuit. So we are in column 20 of the breadboard. The current flows from the red down to the brown, and it goes to a multimeter, and we read 0 ohms. So it's acting as a wire basically, so it's a short circuit because there's a hidden wire down below in there. Now I'll switch to the second circuit, which will read our resistor. And here is our second circuit, and this resistor should be 10 kilo ohms, and the resistor resists the flow of current flowing through the wires. So the current flows through our red positive wire, goes into the resistor, flows from here into the resistor, comes out and goes back to our brown wire, and goes into our multimeter, and gives our measurement value of 10 kilo ohms. And that 10 kilo ohms is the same as our resistor 10 kilo ohms. So our measurement was complete, and this circuit was successful, and the measurement is reading 10 kilo ohms from the multimeter. It completed the circuit and was connected correctly to read the resistance of 10 kilo ohms on our multimeter. And now I'll switch to the third circuit. So now I am on our other circuit, our third circuit, which is connected to the negative and positive terminals of the breadboard. So it flows from the red, but the breadboard, it's connected horizontally now instead of vertically. So it runs all the way down to the other positive side, and same goes for the negative. So it's an open circuit because when we look at our multimeter, we get OL, which is overload in our mega ohms. And this means the open circuit means the measurement from the multimeter reads overload. So the resistance is too high to measure, and these are disconnected wires because they are not connected to anything. It ain't going back. Now I'll switch to my next circuit, and I will be using column 40 and 42. And this is an example of our fourth circuit. So our current flows from a red wire, but it only goes vertically in this column. And then our negative wire flows only in column 42 this way. So this is also, so when we go look and trace it and read our multimeter, it is OL, which is overload. So the measurement from our multimeter reads overload, so the resistance is too high to measure, and these wires are open circuit, which means the wires are disconnected. And that was the fourth circuit. Now we will move on to our last and final circuit, and I will set that up real quick. So now we are on our last final circuit, and we are in the negative terminal of the breadboard on both sides. So the current will flow from the red terminal down into the hidden wire, the negative, and the wire travels horizontally all the way to the other side of the negative and goes through the ground, and it reads to our multimeter, and we get 0 ohms. So this acts as a short circuit because there's a hidden wire underneath. It acts as one big wire traveling across. So the measurement from the multimeter reads 0 ohms, so the internal wire connects with the other two wires, making no resistance, and connects to the hidden wire below. And that concludes our lab 1 circuit, and I believe that is it. Yep, that's it for our lab 1 circuit. So we measured the resistance in different forms of open circuit, short circuit, and the actual reading from our resistor. I did 5 examples just describing from the breadboard, but that's how we understand how it reads and flows through the multimeter and gives us our reading and what those readings tell us from our breadboard and our circuit. So that concludes lab 1, and I would just like to say thank you, and that's all folks, and we will see you in lab 2.
The resistor to